Well, okay, the first thing we need to do is we need to define the numerical grid that we are using. We have to agree on the grid configuration. Where are the grid cells? Where do we calculate U? Where do we calculate W? Where do we calculate density and other scalars? Okay, and this is how it looks like here in this. This is again the Arakawa C grid. Again, this is a grid that's very often used. It's a staggered grid. The grid points are not located for variables, are not located at. Okay, so this is how it looks like. So essentially we have a grid cells, okay? And we can select any of the grid cells using two indices. One is called K as the horizontal one. Okay, K going from 0 to 1 to 2 to 3 to 4. Okay, and we have a horizontal grid spacing, which is called delta x, and for simplicity, it's all constant. Okay? And in the vertical, we use something called I, and I is 1. It's the uppermost grid cell, and what we call NZ is the one closest to the seafloor. And then we have a ghost cells. The 0 one is not shown here, but NZ plus 1 is also. Okay? Constant vertical grid spacing for simplicity, and this. And so now where we calculate the variables is we have where these blue crosses are. This is where we calculate any scalar, like pressure, like density or temperature and salinity. All these features are calculated, or concentration you want. Okay, and to the right and to the left are U velocity grid points, and above and below are vertical velocity. Again, you can imagine that you have a control volume that you can replace, that you can put around any of these pressure grid cells. And this is how it looks like. And you can also use variable symmetry. You can define regions that always remain dry, where there is no predictions done. You can define coastlines or seafloor, horizontal coastlines if you want. And this is done again by just making assumptions for the velocity components. Just set them to 0. There's never a flow across a boundary. Okay, so that's the first thing. Okay, now you can print this out, put it onto your wall. Okay, and this is now the agreed numerical grid that we'll be using.